this would be the radius of that circle. Because if I were to go in and draw the circle, remember, equidistant between A, B, and C, right? So here's one circle you could do. I can already see by bringing over my compass that this is going to be the center that I want, because in order to make that radius go up to B, I can see that I had to make the radius larger. But if you don't have a compass, and if you need to prove mathematically how that would be so, you would need to solve for those radii. So here is one radius. I'll do it r sub 1. And then the other radius would be here, and I'll call that r sub 2. I like to find it to the same point. I like to compare it to the same point if I have a largest empty circle problem, because I just do, but you don't always have to. Realize that the distance from here to B is the same as here to C, is the same as here to D, right? So you could pick any of the points that would make that circle. You could pick any of these 3 points that would make that circle. But I do need to find the distance of r sub 1. This vertex has the coordinates 4, 3, and then this vertex has the coordinates, so this would be r sub 2, 10, 3. And I'm comparing it, both of them, to 6, 6. So we just need to find that distance, and we can find those distances very easily using the distance formula. Go ahead and find those distances. I like to leave it inside of the square root. Because then it's just easier to compare without having to do it in a decimal. Although when you're putting an answer into a computer, it is easier to put it as a decimal, so it's easy for us to compare. But then it's easy for us to see here that the square root of 25, which is 5, but since 13 isn't a perfect square, I left it in the radical. It's easy to see that the square root of 25 here is going to be our largest one. So this is going to be the radius of our largest empty circle, and then this is going to be the coordinate of the center of our circle. So the answer to this coordinates of the center would be 10, 3, and the radius will be equal to 5, which is the square root of 25. And that's how you would solve for these problems, is that you would need to say, okay, the center is going to have to be at the vertex, and then in order to figure out which one would be the largest empty circle, I then have to solve for the distance of the radius to figure out which is the largest radius. E basta. Okay. IB examples, I want to make sure that we get to IB examples, so then that way we can see what we're looking for in regards to IB level test. A farmer's field is modeled by the square shown below. You can see it here, with each unit representing 10 meters. Feeding stations for the cattle are positioned at the points that you can see are labeled on the coordinate plane below within the field. It says find the midpoint of the line segment BD. Go ahead and do that on your own. Remember that midpoints are just the average of your values. And so since B is 210 and D is 8, I just need to find the average of those. So 2 plus 8 divided by 2, and then 10 plus 8 divided by 2, just averaging out my X values, averaging out my Y values. And that would be 5, 8 as my coordinate. 1 mark means that it's just, did you get the answer right or did you get the answer wrong? And it's just 1 mark because it's supposed to be kind of an easy problem. It then says to calculate the gradient, in other words, the slope of that. I think you can do that on your own. You could have left it as 2 over negative 6, or you can leave it as negative 1/3. You get a method mark for plugging in these values into the slope formula, and then you get an accuracy mark for getting the correct answer. 2 marks. It then said, show that the equation of the perpendicular bisector of the line segment BD is this. And notice We've been doing all the things so far that we need to do in order to make the equation of the line of the perpendicular bisector. So in order to find the equation of the perpendicular bisector, we need the midpoint, which we found here, and we also need the slope. We found the slope of the original guy, so then the perpendicular slope would just be 3. And then we want to go through the point 5, 8. In order to make the equation of a line, we use this form, which is in your formula packet. We would do y minus 8 equals, and continue on. So we've gotten there, but we want to show that we could eventually get to this value. So I want to try and manipulate the form that I already have right now to make it look like the form up here. So I noticed first that I don't have parentheses in my final form, and I do have parentheses right now. And the way that we would get rid of the parentheses is to distribute the 3, so then I don't need to have the parentheses there anymore. I made a mistake. This is 5, 9. And so that's going to be 9 here. This is why I show that problems are great, because it shows you that you made a mistake. I noticed that if I added 15 to both sides, I would not get 6. So then I had to go back and be like, wait, I didn't get the right answer because I'm not getting to this point. So go back and double check my work above. That is not 8. That is 9. 9, 9. Yes, that would be 6. I can do it pretty quickly because A, I have an answer key right next to me. I've already done the problem. And B, I'm a math teacher, so I do things fast. But that is a way for you to be able to check your work, is show that problems force you to go back and be like, oh, no, I didn't get it. So that must have meant I did something wrong. Now, if you didn't catch it or couldn't figure it out, you would still get follow-through points. There would be a way for you to still get partial credit here, especially if you're showing your work. But that is another way in which show that problems are actually really great problems to have and can be helpful in many ways. Now I know that I've got y, but I need my 3x to be on the other side, which I know I can just subtract 3x and then add 15 to both sides. I get 6 equals 0. Haha. I did it. I showed that that was the value. Notice I never once wrote down the actual answer until the very, very end. Okay. You get a method mark for the perpendicular slope because you didn't find that first. You first found just the normal slope. You then get another method mark for plugging in the point and the perpendicular slope, and then your final method mark to get to the final answer, not just leaving it like this. It's assumed that the cattle will feed at the nearest station, so the farmer wishes to construct a Voronoi diagram. Given that the perpendicular bisector of the line segment AD is this value, or this equation, construct the Voronoi diagram for those guys, showing all edges clearly on a diagram like the one below. Okay, so it doesn't ask you to actually find it mathematically. And so this is a way that what we did earlier in our notes could be very helpful. We already have an equation for one perpendicular bisector, which is AD. It's in mx plus b form, so hopefully it feels pretty easy to graph. The y-intercept is 10. The slope is down 1, right 1. So it looks something like this. So if that's AD, and then I just found the equation for my perpendicular bisector between B and D, and I knew that the midpoint was 5, 9, and the slope was up 3, down 1, I could also just quickly sketch in the Voronoi diagram that way by starting at the midpoint and then going down 3, back 1. Okay, I can start erasing parts right now. I know that this is splitting up BD, so once it hits the point of concurrency, I know that I don't care about that perpendicular bisector afterwards. So it doesn't matter what's going on with A over there. This is between A and D, and it's kind of like in the middle, and those guys get a little weird, so I'm just going to leave it for right now. So I did AD and BD, and then AB is pretty easy. Notice that it's already vertical, so finding your midpoint is going to be pretty darn easy, and we know that the perpendicular bisector will just be horizontal. So it's going to be splitting up the space between A and B, and then I see here, the AD does not matter up here. Then I'll do ADC. Again, we've got horizontal, so perpendicular will be vertical. Again, another easy one. Notice that the one that we had to calculate was a little bit challenging, and then it gave us the other challenging one, and then all of the other lines were pretty easy because it was either horizontal or vertical. And so there you go. A Voronoi diagram, only 4 points, a little bit easier. And I didn't have to calculate anything for this part. All I had to do was be able to quickly sketch it in. And so if you were able to do that first example or get pretty good at doing something like that first example, then these problems on the test shouldn't actually be that hard. You can always do a practice Voronoi diagram by just it could be a doodle that you do in class. Is just put random points and start trying to draw in perpendicular bisectors. You can doodle Voronoi diagrams or just draw it on a whiteboard and kind of have fun with it. Make designs, make it fun, make it interesting. You could even have, maybe if you're a daily sketcher, because that's a part of your artistic creativity expression, maybe you can daily sketch some Voronoi diagrams to also practice with mathematics. Being an active thinker and making these connections between your art class and your math class could be a really, really cool way to have that be a part of your goal as your SSI thinker for this unit. Okay, 5 marks. How these 5 marks would be distributed is you would get 1 correct point for if you had 2 perpendicular bisectors that were correctly drawn here. You would get another method mark. Let me show you what I mean. If you had 4 correct perpendicular bisectors, you would get 3 method marks if all of the perpendicular bisectors were correct. Then you would get 2 accuracy marks for having the correct Voronoi regions, depending on how many correct Voronoi regions you had. That means if you erased correctly or not in regards to those perpendicular bisectors. So that's how the grading of that would have broken down. Okay, it says the farmer now wishes to place a 5th feeding station inside the boundaries of the field. The new feeding station would be at least 10 meters away from the boundary wall and placed so it is as far away as possible from the present feeding stations A, B, C, or D. Within the boundary wall means it needs to be within here, and it needs to be equally far away from A, B, C, or D, and you want it to be as far away as possible, so then that way it's feeding into an empty space that you can accommodate by putting a feeding station in there. So it says determine the optimum location of the feeding station. So this is our toxic waste dump problem. We want to find one that's equally distanced away. So we're talking about the vertices, right? So either here or here. So it's either going to be 5, 5, or it's going to be 4, 6. And we want to figure out which one of those would give us the largest circle. So I could compare it. I'm going to pick to choose both to D. So I'm trying to figure out which of these 2 radii is going to be bigger. And I'm going to find the distances between those 2 and use that in order to determine which one would give me the largest empty circle. So then that way, if I placed a new feeding station there, I would be able to feed into a space that has large distances between the feeding stations. Okay, go ahead and find those distances on your own. I won't have you type it in, but I do want you to try to find those distances. Okay, leaving it in a square root so it's a little bit easier to compare, and I don't even have to type anything into my calculator if I don't need to. I can see here that the square root of 20 is larger than the square root of 18. So 4, 6 would give me the largest empty circle. So it says determine the optimum location of the new feeding station, and your answer would be 4, 6. That would be the best place to place your new feeding station. So then that way you're feeding more cows and providing it in a more convenient location. So this is a classic IB problem. What I would like for you to do for the rest of your homework is do a smaller problem. This is a paper 1 problem, as opposed to this guy would be more like a paper 2 problem because it's got a lot more points. I'd like for you to do this one on your own, and I'll check when I see you next that you've completed it. And then we'll go over the answers together in class. Good job today. I'm sorry that these notes are long.